Imagine hurtling down a near vertical mountain at over 100 kilometers with no legs or blindfolded or using a sit ski that's basically a rocket sled on snow. Right now at the Milano Cortina 2026 Winter Paralympics in Italy's Dolomites, Para Alpine skiers are doing exactly that and winning medals in events that just started this week. But how? How does physics let them defy gravity like this? Today on Everyday Phenomena Explained, we're breaking down the mind-blowing science behind their speed. Stick around, this one's wild. Welcome back to Everyday Phenomena Explained, where we unpack the hidden science in the things we see every day, or in this case, the extraordinary feats happening live at the 2026 Winter Paralympics. Para Alpine skiing includes downhill, Super G, giant slalom, and more across standing, sitting, and visually impaired categories. It's the same gravity, friction, and momentum we all experience sliding down a hill, just pushed to the absolute limit. Let's dive in. First phenomenon, gravity. It's the force pulling everything toward Earth, and on a steep slope, it becomes the main driver of speed. In everyday terms, when you slide down a playground slide, gravity converts potential energy, height, into kinetic energy, speed. The steeper the angle, the bigger the downhill component of gravity. For para-alpine skiers, slopes can hit 60-70 degrees in downhill sections. That gravitational pull is massive. The force downhill is mg synthint, where m is mass, g is 9.8 mem/q-trade, tha is the slope angle. Bigger tha, bigger synthint, faster acceleration. But here's the twist. In sitting category, athletes like those in sit skis have a lower center of mass that makes them more stable against tipping, so they can handle steeper lines without flipping. Standing or visually impaired skiers adjust by leaning aggressively, sometimes way beyond 45 degrees to keep balance while gravity rips them downhill. Next up, friction. Snow isn't ice, it's grippy, but pros make it slippery on purpose. Everyday skiing friction comes from ski bases waxing and snow crystals. In para-alpine, friction is even more critical because adaptive gear changes contact. Sit skiers have one wide ski or monoski. Less surface area means less friction, but they use outriggers, short poles with mini skis for balance and propulsion. They minimize drag by perfect wax, sharp edges, and positioning. Air resistance drag is huge at high speeds. That's why they tuck low, reducing frontal area. Drag force scales with velocity squared, so having your exposed area can boost top speed dramatically. In turns, they carve by edging, tilting skis so edges bite snow, creating centripetal force without much skidding, which wastes energy via friction. Watch this slow-mo. The skier leans in, edges dig, and they arc smoothly instead of sliding sideways. Phenomenon 3, center of mass control. This is everyday physics on steroids. In a car turn, you feel pushed outward. That's inertia. Skiers fight it by moving their center of mass inside the turn. For standing skiers, they incline their whole body. Ankles initiate, hips follow. So travels in a straighter line while skis arc underneath. Sit skiers, their cum is super low, almost on the snow. That lowers tipping risk and lets them lean insanely far without falling over. It's like banking in a plane turn. The forces align so gravity helps hold the line. Visually impaired skiers with guides shouting directions do the same but rely on voice cues for perfect timing. This cum shift is why they can hit tight gates at 80+ km/h without crashing. Here's where adaptation shines. The gear turns physics challenges into advantages. Sit skis are carbon fiber buckets on a single ski. Low drag, low com, shock absorbers for bumps. Outriggers act like mini skis for balance and turning force. For limb differences or vision impairment, bindings and poles are customized so force application matches Newton's laws perfectly. Equal and opposite reactions for propulsion and control. Even prosthetics or guides become part of the system, optimizing momentum transfer. Put it together. Gravity accelerates, low friction sustains, calm control directs, gear minimizes losses, top speeds over 120 kilometer ain and downhill, same as able-bodied pros, sometimes faster in sitting due to aero advantages. Right now at Milano Cortina 2026, events ongoing through March 15, watch for records in women's/men's downhill. Athletes like those from Team USA or stars in VI category are pushing these limits daily. So everyday phenomena, gravity pulling you down a hill, friction slowing your sled, balance keeping you upright are the exact same forces letting Para Alpine skiers become superhuman on the Dolomites.